Hey everybody, so this is the third part of our Q3 review. Especially important for the EOC test. Again, a bulk of the information comes from this section, okay? We last left off with question 18. We're now moving on to question 19. It says multiply using the special product formula. I do not want you to do that. You've learned so much stuff that you don't really need to know the special product formula until probably several math classes ahead of us. Your goal is to pass the test. So as long as you can see that those are two binomials and they want you to multiply them, what do? We use the box method. So yes, there is a special formula you can learn, yet another one. We don't need to memorize any more stuff for this class right now. I just need you to learn how to do it and get it done. Lots of tools in our toolbox, so just figure it out, okay? So again, the minus sign here is very important, so we throw that minus sign in, and the other one is a 6x and a positive 9. Okay, box method, we multiply to get into the box, we add to get out, so 6x times a 6x is a 36x squared. 6x times negative 9 is going to be, 54? Negative 54? And then we have a 6x times a positive 9 is a positive 54. Of course, the x is there. And negative 9 and a positive 9 is a negative 81. And that's one of our perfect squares. Notice what just happened here in this middle. And this is why they say special product formula. Why? Because something special happens. Our middle terms, when we combine them, they cancel out. Negative 54x, positive 54x goes away. We're left with a 36x squared minus 81. So I'm going to rewrite it here. 36x squared minus 81. And you are done. That's it. A box method always works when it comes to multiplying polynomials. So again, if you've memorized that special formula, great. Kudos to you. I just do it the long way. We have time on this test, so don't worry about it. Okay? Next one says 20 says factor the trinomial. Okay, so factoring a trinomial, we know we have a few different methods. Leading coefficient, or A. These are all being determined as ax squared plus bx plus c. C is the constant. B is the term. It's the constant. It's also your y-intercept for your equation. B is the coefficient on x, and A is the coefficient on the x squared. Few things to remember. This is a parabola that points up. Okay, if this number outside here happened to be negative A, then it points down. Remember, the sign determines whether it's pointing up or pointing down. Let's not get too confused about that right now, though. We're factoring. So we have our little organizational chart here. We have C goes on top, and our B goes down on the bottom. So C, in this case, is a negative 28. B was 3. Okay, so we need to list what are the factors of 28. You could just list a few. Okay, so you know it's like 1 and 28. We know that it's what? 2 and 14. 3, is 3 one of the factors? No, because it doesn't go into 28 evenly. 4 and 7. And you can keep listing them and listing them and listing them, but we also are looking for the second part of it. Not only do we want the factors, but when we add these factors up, they need to equal 3. Okay? So remember, this is a negative 28, so one of these numbers are going to have to be negative. So it could either be 1 and negative 28, or maybe negative 1 and a positive 28, but they need to add up to a positive 3. So look at the ones we have here. I can already see this here. We need a positive 3, so the bigger number is going to have to be the positive one. So if we go through here and make all these numbers negative, but so this gives you, if you add them, 27, this gives you 12, this one gives you, ooh, this is the one we want here, negative 4 plus 7 is 3. We are ready to put our answer down. Our variable that we're using is x, so we can make our two binomials with our variable. And then these numbers that we chose right here, we simply drop them in here to make two binomials, negative 4 and a positive 7. There we go. If you were to stop, take a minute, check your work, box method this together, what are we going to get? You're going to get this right here. Okay? Let's look at the next one. They're using the same thing we just learned above, but in a word problem. We have the area of a rectangular rug. Okay, and that rug is given the trinomial r squared minus 2r minus 35. What are the possible dimensions of this rug? So if you're going to do length times width, like we did here, maybe length times width. What do we have to do with this quadratic they gave us? We have to factor it. Okay, so we can do our little cross. Our c is a negative 35. We have a negative 2. Let's list some factors of 35. Well, 1 and 35, that's not going to work. Notice that our b is negative, so that means this time the bigger number is going to have to be a negative number. That gives us like negative 34. I don't think of anything off the top of my head for 2 that goes into 35. Nothing for 3, 4, 5. 5 times 7, that's a factor of 35. If the big one's negative, well, negative 7 plus 5, hey, this right here gives us our negative 2. Like we did before, we're going to write our parentheses because we're factoring it. Our variable this time was an r plus 5, and r minus 7. Now, some of you are going to take that and stick it straight into the answer, and it's going to be wrong because you have to read directions. It says use a comma to separate each answer. If you write it with the parentheses, okay, you still have to put a comma between it. So that would work as an answer, or you could write r plus 5, comma, r minus 7. And the only reason why you could put this in as an acceptable answer is because you're dealing with something that's sort of real world. You have a side. You wouldn't necessarily, there's no need to wrap a parenthesis around it because we're just listing the sides. So the computer will take either one, but I would put it in this way, r plus 5, comma, because it said to separate your answers as needed with a comma, r minus 7. Okay? Look at this. This one says factor the expression. Notice what has changed in this expression from the previous one up here on question 20. A is now a number, so we have to use the method that is a little bit longer. Thankfully, I have extra room here. This is the AC method. A times C. And then the B. So the B is 20. We have to take A times C, so 3 times 12. 3 times 12. 36. Okay, now we have to figure out, well, what are the factors of 36? We're looking for factors of 36, but we're also trying to look at them like when we add them, which ones give us 20? So we have 1 and we have 36. That doesn't work. We have 2 and 18. We have 3 and 12. Let's just stop here because I could do 4 and 9. I could do 6 and 6, but I'm looking for when I add them together, which ones give me 20. Look, 2 plus 18. Here's the ones that work. Now, this so far is pretty similar to what we did, but this is where it changes. Okay, we don't just drop this into a set of binomials like we did up here. We have to use these pieces to rewrite our middle term. We're not changing any values. It's still they'll still total up to 20y in the middle, but we're rewriting that 20y as a 2y and an 18y. Okay, and watch, you'll see why. 3y squared. Grab the first one, plus 18y plus 2y plus 12. Algebraically, I have not changed the value of this. 18y plus 2y is still 20y. What this does for us is that this allows us, and I'm going to try to change colors. Hopefully it'll let me do it. What this does is it allows us to sit here and we can now factor by groups. We have 2 groups. Factor by groups, that's what we did on the last set. You're going to do one set first. What's the greatest common factor, the GCF of these two? So we look at the 2 coefficients. 3 is the smaller one. Does 3 go into 18 an even amount of times? Yes. And then we stop here and we say, okay, do they both have a y? Yes. Which y has the smallest degree? Well, this one here. It's y to the first power. There's our greatest common factor. Okay, how do we fill in this middle term? We have to divide this whole thing by our greatest common factor, a 3y. Okay, so 3y squared divided by 3y is just y. 3's cancel, and 2 minus 1 leaves us just y to the first power. 18 divided by 3 is 6. Y divided by y goes away. Okay, now we have to do this next side. 2 and 12. The smaller coefficient is 2. Do they both have a y? No. Okay, so you're ready to go. Divide this entire side by 2. 2y divided by 2 is just a y. 12 divided by 2 is a 6. Perfect. Notice what's in the parentheses is exactly the same. That's what's supposed to happen. Now all we do is we can, out of this term, we can factor that 6 plus y out. I'm sorry, y plus 6. And if you were to divide both sides by y plus 6, and divide this one by y plus 6, the only thing that's going to be left, because this cancels this, and this cancels this, is you're left with the 3y plus 2. Box method that back together, and you've got this one right here. All right, the AC method. Jog your memory. That was from, I believe, chapter 8 in our textbook. So look at your notes there too. This again here, guys, it's the same thing. I'm going to help you get started just a little bit. Remember, if this is the AC method, I'm not going to do the whole one for you. You're using the AC method. So negative 5 times 12 is a negative 60. Your B is negative 11. And you need to find those factors. What are the factors? Well, I know factors of 60 are obviously 1 in 60. That's not going to work. We have a 2 in 30. Uh, 3 times 20. 4 times 15. Notice our b is negative, so this bigger number here is going to be the one that's negative. If we add these up, look, these here are the ones that we're looking for, 4 and negative 15. So then you can rewrite that middle term. 12x squared plus 4x minus 15x minus 5. And just like the last one, I'll leave you to finish this. Factor this by groups. Factor that by groups. Okay, not so bad. 24 is going to be exactly like 20. This is the easy one because it is a is a 1. So you see what two things multiply. What are the factors of 16 that add up to b? And in the very end, you will have your 2 parentheses. Your variable was an x. Whatever these factors are here, that's what you dump in here. Okay? Oh boy, look at this next one. Factor the expression. Notice that there's something interesting that happened here in this one. Okay? This is a special case, and this is one of the ones that you do want to remember. Okay? The special cases are, we look at a couple of things. If the first term is a perfect square, if that's a perfect square, this is a subtraction sign, and that is a perfect square, we are ready to factor it without doing pretty much anything at all. This is the sum and difference method. Sum and difference method. So put a plus and a minus in each one. All we're going to do is take the square root of the first term, take the square root of the last term. Well, the square root of x squared, square, and the square root cancel and leave you with an x. Square root of 36 is 6. That's it. You're done. This was the special case one we did up above where I told you there was a special formula for it, but you didn't really need to do it because what happens is that specialness is that the center terms cancel out. In factoring, you should notice right away, hey, I only have 2 pieces. This is a quadratic, which almost always has 3 pieces. Something funny is happening, something special is happening, and you check it. Perfect square, subtraction sign, perfect square. If it is, you can set it right up into this little formula and drop your stuff in, and you're good to go. 26, here we go. This has to do with, we have to look at the different things, and they're trying to confuse us here. Okay, we have to be very careful. We had that, the standard form for quadratics up here. Where did I put it? That's up higher. Oh well, I'll just rewrite it. The standard form for quadratics is a x squared plus bx plus c. This number here is what, that coefficient a is what's going on here. If a is positive, it points up. If a is negative, it points down. Okay? The smaller a is, the more wide that parabola is going to be. The larger a is, the more narrow that parabola is going to be. So if a, let's say, is a fraction, it generally makes your parabola very wide. Okay, if a is a fraction, like an x A is x over y. It makes it very, very wide. If A is like 10, it makes your parabola very narrow, shrinks it back up. Now somebody says, oh, well, -2, that's a pretty small number. No, no, no. Don't worry about the sign. Remember, we said the sign determines if it's pointing up or down. So when you're looking at A, don't pay attention to the sign. You're looking at the number itself. Which number is bigger or smaller? The only thing the sign does is determine if it points up or down. So let's look at this one. Y equals -2x squared. Okay, negative. That means it needs to point down. B is not right. D is not right because they point up. Now, we need to say this, okay? If A is a small number, it's supposed to be very wide. This one is really wide. This one is not. It's pretty normal shaped. Looking at a number line from 0 to 2, 2 is not that far off from 0. So this is your selection here. If you wanted to test your theory, you can test it. You can go in here and take a look at some of these, like 2. You should notice that if these are going by 5 here, if you plugged in a 2, you should be somewhere between, your answer should be between 5 and 10. So 2 squared is 4. 4 times 2, -2 is a -8. So this is between 5 and 10. So this is -5, -10. Right about there. That would be about a -8. So that is definitely a way you can check your answer. 27 here says, order the group of quadratic functions from the widest, or the one that has the smallest a value, regardless of sign, to the largest, because the smallest number makes the widest graph. So we have a -3/4. Don't worry about the negative sign. 3 and a -2. Don't worry about that negative sign. Take just the a values and put them in order from least to greatest. So the fraction is the smallest. That was a very horrible 2. Then we look at the next number. Well, that's 2. Well, yes, there is a negative there. So -2x squared. And the last one is a 3x squared, because 3 is bigger than 2 and 3 is bigger than 3/4. Notice it didn't say put them in order from widest to narrowest with ones that are pointing down first and ones that are pointing up next. No, it just said put them in order from widest to narrowest. So we can look, this one points down, that one points down, this one points up. This one's the widest, then it's this one, then it's this one. Okay, and which one does that fall under? Right here. Notice this one is backwards, it wouldn't be this one. This one, they swap these two around, so it couldn't be this one. This one again is backwards. Nope, this one's not in the right order. And that one wasn't either. So yes, F was our correct answer. All right, guys, that's it. There's another 9 problems down. Got just a couple more of these review sessions to go.